thrilled to be here on this panel of the role of machine learning in climate change with such fantastic panelists. So here we've got Jules Andrew. She is the Senior Vice President of Strategy, Transformation, and Enterprise Operations at RBC. Jules is responsible for developing and executing strategy in support of RBC's goal to be digitally enabled, responsible, and a relationship bank and transitioning, and transforming shared services, including finance, to enhance RBC's industry-leading position. Her team facilitates money movements for clients, suppliers, and employees, and ensures that branches and ATMs have cash. Jules has held leadership, financial, and operation positions across the globe with IBM and RBC for over 20 years and has lived in 5 countries and visited 58. We've also got Sasha Luccioni, who is a postdoctoral researcher at the Mila Institute. She is working with Joshua Bengio to fight climate change using artificial intelligence. She leads projects at the nexus of AI and climate change, using generative networks to visualize the consequences of climate change and tracking the carbon footprint of AI. Sasha is highly involved in community initiatives, serving on the advisory board of Kids Code Jeunesse and as a chair of the Climate Change AI Initiative. And we finally have Arthur Berrill, who is the head of data science at RBC. His charter is to research, guide, and deliver data science capabilities, including location intelligence, new data content, artificial intelligence, ontology, and climate change studies across all departments of the bank. He is an RBC distinguished technologist with more than 40 years of experience in architecture, design, and development of enterprise spatial systems, including WildMap, a GIS term, a GIS system before the term existed, System 9, Spatialware, and MapInfo products and Location Hub. Prior to RBC, Arthur led the Location Intelligence Initiative at Scotiabank and was president of DMTI Spatial. And Arthur was Inventor of the Year in 2008 at Pitney Bowes MapInfo and won the Tech America 50th Anniversary Innovation Award in 2009. So welcome all, and thank you for making time to be with us today. Let's start the panel with the question of whether or not you see any potential impacts to enterprise operations that are believed to be caused by climate change. Jules, do you want to start with that question? We can't hear you, unfortunately. Okay, so one of the next questions that we have is, what is standing in the way of AI making more of a climate impact? Sasha, do you want to start talking to us about that question?
Sure. I think that what's really missing is the connection between research and practice, research and deployment. So we've been organizing, for example, workshops tackling climate change with machine learning for over a year now. And there's some really great ideas, but there's very little. I mean, that's the thing. So researchers have great ideas, and they test it in labs, and they, sometimes even create a prototype. But then the next step, for example, either getting VC funding or deploying it. For example, one example that comes to mind is that we had someone come present an AI-based system that could reduce by 2 to 3% the emissions of an average flight by essentially detecting wind speed and things like that, and essentially autopiloting around that. And then we were like, this is major because aviation is such a big industry and emits so much, right? But actually deploying that in a bit like in a commercial flight setting would entail so much, right? You would need so many checks and balances and financing, et cetera, et cetera. And so it's always kind of this trying to figure out how to, take this cool AI and this cool algorithm and then deploy it in the real world and make sure it can actually work. So that's, I don't actually know what's missing there. Is it incubators? Is it funding? Is it startups? Like I think there's a lot of pieces to the puzzle, but that's what it would really take. Jules.
Mm-hmm. That's right. This again.
Hi, Jules.
Can you hear me? And I swear I did not move the iPad, so I'm not sure what's going on.
There she is.
Technology at its best. Arthur, obviously, I need a little more help on machine learning with my Hopin tool set. So sorry about that. So on the operations side, I mean, we are a logistics operation of getting cash and checks moved, whether that's in Canada, the Caribbean, other locations. And, the ability to manage that with some of the external data on what's going on with climate change, whether that's snowstorms, as I'm reminded, we've just started having some snow up here, or hurricanes, which we've seen a record number of hurricanes coming through the Caribbean this year, and expect, you know, that to continue to be volatile. So as we think about climate change, it has a lot of impacts across our business as we look at, you know, movement of that actual flow of cash. And I know people think we don't use cash anymore, but we do. And we use checks. And although the digital forms help us in offsetting some of that, we do still need to be there for our clients. So that's a lot of the work that we do with Arthur and the team.
Mm-hmm. Got it. I think that ties well into what.
Patricia, can I do a follow-on to Sasha?
Please, by all means.
Because you posed a really good question there, Sasha, and I was thinking it needs, for these things to get traction, there needs to be, the big businesses need to make some moves, make some changes in adopting machine learning for climate change. There's a quote that I'm very fond of trotting out that was used at the Green Horizon Summit that was just last week. And Mark Carney, who should probably need no introduction here, I'll read you the quote because to me, that was that if that is adopted and that move followed, then I can see the machine learning connection with climate change accelerating dramatically. So he said, he described the process of stopping the rise of global temperatures as turning an existential risk into the greatest commercial opportunity of our time. So he is literally saying that if businesses get engaged in this, there's an enormous amount of profit to be made. And if that's the case, then that's going to drag machine learning kicking and screaming right into that space. So instead of POCs, you'll have real implementation across the board. Mm-hmm. Just some extra thoughts, Sasha.
I agree.
There's a relevant question from the audience here. Tyrone is asking if there's a lack of high performance compute resources for deploying machine learning algorithms for climate change.
Can I take that? So there's not a lack of resources. There's a lack of access to resources. So, I mean, resources are provided by, for example, big cloud providers, and you need to have money in order to access them. So we've seen typically that, especially if we want, for example, technology to percolate in areas where they don't necessarily have GPUs in-house, the barrier to entry really has to go down. And also given the amount of energy and the amount of computing that we're currently using, this is not typically something that you can do on a laptop. Like, so AI in the 90s and 2000s were really something that you could code up on your laptop and you didn't need any access to anything. And then we made this great theoretical progress. But nowadays you really need to get access to GPUs, now TPUs, and a certain amount of them. So I'm seeing this really kind of divide between the people who have access to these TPUs, who can publish, who can deploy, and the people who are trying to do this in low resource settings. Like we're in contact with, for example, climate scientists in Ghana who are working on a cloud computing cluster in Italy because they take turns and they don't have access to this in their own country. And so there is this kind of barrier to entry that needs to be kind of figured out, and how to allocate resources in a way that is not, is not a barrier for people who don't have that money.
So I have a couple of points, Patricia, if I can join in here. I think it's a really good question. Underlying the question, though, is the size of the data that we deal with. And my experience with climate change data is that the data is so immense that it pretty much dwarfs many of the other machine learning exercises that we undertake. So first of all, yes, the need for high performance compute for these algorithms definitely holds us back. The second thing, though, is deploying those massive resources actually contributes to climate change. So you get a nasty little circle there that it would be very nice to actually find a better way of solving that. Thanks, Patricia.
Yeah,
thank you, Arthur.
Sorry, just one more thing on that as well, right? So the work that we do across we have an artificial intelligence arm, Borealis, that's located near Mila, Sasha. So, it's working in partnership, right? I think we're seeing more and more partnership in this space with the academic institutions and other groups and other partners trying to work together to that point of being able to find the path forward and hopefully not just generate more carbon emissions by building out these platforms. But I think we're going to continue to see more growth in that space as well.
Do you think that overall, from an environmental perspective, AI is doing more harm than good?
I think that it's, as Arthur said, there's a trade-off to be made between, essentially, it's being mindful. I think that mindfulness is part of it. And I mean, I guess it's a generic concept, but essentially making sure that we're serving a purpose and making sure that the way we are doing research makes sense. So we're not just, using more data just because we have more data, using more power just because we have more power. Because it's true, it's kind of like, well, I mean, typically in the Western world, we have these resources. So it's like, hey, I can train my network for a month and see what happens, right? But it's not necessarily going to give me any improvement. It's just kind of a trial and error thing. So, for example, we've been working in order to create a calculator. We called it Code Carbon, and it will run in the background and actually give you an estimate of the emissions that your code, your AI algorithm, whatever, emitted at the end.
Oh, nice.
Yeah, we're actually launching in a few weeks. And so the idea is that it's going to just run in the background and at the end give you a little like printout saying, hey, this is how much you generated and this is how much you could have saved by taking these steps, like either deploying on more efficient architectures or in a grid that's connected to renewable energy and things like that. So the idea is really to not like shame people, because some networks do have to be trained for like reinforcement learning needs a lot of training time, and that can be fine, but you need to take steps to make sure that you're not just training on a server that's connected to a coal-powered plant. So, like that's just connect to Quebec power plant. It's hydroelectricity, right? So it's like there's some.
That sounds like an incredibly useful tool and like something that companies can integrate internally to limit their impact. Is there anything else that one of you would like to point out that companies should be doing internally, both to prevent or limit their climate change impact and also prepare themselves for any sort of climate change related disasters that are likely to occur?
I can throw one thing into the mix. Right now, these studies tend to be very large scale. Right? Even within a company, it's like, okay, what's our overall carbon footprint? You're a 10,000 person company, and it's going to be a big number, but does it really mean anything? I think one of the big things that we need to do is get this very fine-grained and have that fine-grained understanding that lets us then aggregate it up into the most significant areas, right? And I don't think right now that's being done, but I think there are some big organizations around the world that can provide that as a capability and let you drill down to the more fine grain. I mean, when all of the small to medium businesses are now starting to pick up, when they pick up on, I need to understand what my carbon footprint is because my shareholders are making a noise about me being responsible, climate responsible. At that point, those fine-grained things suddenly become incredibly important. We've got a stack of questions,
Yeah.
Patricia.
Yeah,
That's great.
So one very relevant to what you were just saying, Giacomo is asking what kind of first steps the organization can take in terms of measures to limit their impact on climate change.
I can take that. So there's different parts of the question. There's the kind of individual carbon footprint question, and there's actually lots of resources for that. It's ballpark, but at least it tells you, like, for example, how much carbon more or less you emit via your diet, via your transportation, even like your buying habits and things like that. So there's some really good ones like that exist. And then there's even some that say, oh, well, if everyone had the same carbon footprint, it would take these many resources. So it's pretty, actually, like, for example, I even discovered a carbon offsetting subscription service. So essentially you do all these calculations and you say, I take my car, public transportation, I fly, blah, blah, blah. And then it gives you like a ballpark figure that you can offset every month. Like you've got your Netflix and you've got your carbon offset. So, that's one way of doing it. And of course, that's kind of for your day-to-day citizen, kind of anyone. And then there's the tech footprint, and that's a bit more tricky. So that's what we've been trying to figure out. So we've been focusing on compute as such, but there's also so much more to it. There's like the life cycle of computers, the life cycle of technology in general, So all of that, like the professional carbon footprint, as I see it, is a lot trickier. It's a kind of a whole can of worms.
So we've got a really interesting follow-on question by Ushnish, where they're asking if there are any AI applications for climate change that explicitly use renewable energy resources for their computing power. Do you know of any?
Wow, good question. I don't know of any.
So typically what's been done currently in the big cloud providers, so Google, Microsoft, AWS, for example, there's mostly they've been offsetting a lot. And so how this is done, there's renewable energy credits. Essentially, for example, if a server uses X kilowatts of energy, they'll try to buy that renewable energy and put it back on the market so someone can use it. So that's kind of the typical way things are doing. And the big tech companies are really good about that. But more and more, they're also using renewable energy. So there's a few server instances, both from Google and Microsoft, that are either solar powered, wind powered, or tidal. So that's really it's really good. It's part of the process, but it's percolating and it's becoming a more of a transparent process. This is really good. And actually, in a very meta way, Google, for example, is using AI to reduce the amount of energy that they're consuming. Essentially, they trained a model that will like allocate resources more efficiently, and then essentially in real time, it'll like dispatch processes, and they cut their costs by like, I don't know, 40% or something. So the tide is turning. It's really actually exciting.
Fascinating.
Hey, Patricia, I have something I can tack on to Giacomo's question, which I thought was a pretty good question. So as a company, you pay certain bills. So one of the things you pay is your hydro bill. So the generating and delivery process of hydro is reasonably well understood at a very large scale. So we know how much carbon Hydro One generates from their generator plants. We know how much carbon is involved in the delivery of that product. So you, as buying your $1,000 worth of hydro a month or whatever it turns out to be, you're assuming some of that carbon debt. So that's a pretty easy place to know that you're actually what your influence is. You can't necessarily do that for all transactions, but if you start at a small scale, things like that will make a difference. You can pick that information up. Now, this is not really a machine learning answer, but it's a good question from the point of view of climate change.
Super interesting. So I think what we've covered is that we can use machine learning to predict how much carbon is being emitted, to limit the amount of emissions that are being produced. And we could use these external sources like Hydro One bills to inform that process. Is there, like Hyung Han is asking, a role for machine learning for climate change prediction?
Yeah,
well?
Actually, so as Arthur mentioned these huge climate models. So typically how climate prediction has been done, you have these physics-based models. So essentially they actually try to model all these phenomena like, I don't know, water evaporation and like microparticles and things like that. So they've been very resource heavy, and they've used traditionally high compute power. And so now machine learning is helping kind of simplify those models and try to and essentially glean insights and to make them a bit simpler and more optimized, and so we can run faster. And for example, there's also like long-term prediction, medium-term prediction, and short-term prediction. So there's kind of different use cases for machine learning in each one, depending on what the factors in play are. For example, one example that I really find interesting is that, for example, for renewable energy, for example, solar or wind, you need to know exactly what the temperature and the wind and the sunlight is going to be in real time, right? And so, for example, machine learning can do what they call nowcasting. It can look at satellite imagery of like a cloud coming by and can say, okay, there's a cloud on the horizon in 20 minutes, your output is going to go way down. So you have to like charge up a battery and make sure you can like, keep the output steady. And so there's things like that are really cool, because it's a mix of like computer vision plus some prediction plus some inference. And essentially cloud's actually really tricky because you never know which way they're going to move in. So machine learning can really help with that.
I think there's a hybrid here too, that Sasha was implying that. So there are certain models that are reasonably well established from the physics, but they don't bind together. So a lot of the work that we've done in climate change has been, well, as you can understand sea level rise here, and you can understand weather change patterns at a very granular scale across the country. But all of those pieces work in silos. So you've got people who are deeply committed and technologically involved in the process of understanding sea level rise. But I think there's a play for machine learning to take all of those models as contributors to an overall model, rather than just saying, oh, I got so much carbon from here and so much carbon from here. That's a static story. But if you want to be predictive, then you take the trends that you're picking up from all of these physical models and you put them together with a machine learning model.
Yeah, I mean, and I know Zayed, I think it's scooted up off the screen there because there are so many questions coming in, was asking about kind of the payback and how you look at those projects. And so that's a lot of the work that we've been doing with the team. And it's taking that machine learning algorithms, but taking that data and thinking of, so how does that mean we can actually change that operational flow of the number of armored cars going out, how the actual physical cash moves around. And I think one of the things that as we go along with this is that trying to, figure out those predictions of exact cost savings down to 3 decimal points can actually just be a prohibitor, right? I mean, what I would say is that, and there was a question about what retail companies can do. I think some of this is, we know the cost of movement of things, as any retail company would, and knowing that there is a cost to that as well from a carbon footprint perspective, and needing to take a leap, right? And say, okay, let's start working on this. Now, I have to say, one of the models we were working on for this cash forecasting tool, ever so brilliantly, we decided to implement it March 1st. And obviously had to hit the reset button, but we'd been working on it for some time. And then, again, I think it's just this continual pivoting and going, okay, now I need to have a different set of information, because obviously the way that consumers are acting and utilizing branches is different than it was, a year ago. So I think it's about knowing that the model will eventually lead to the ability to change the way that you're fulfilling. And we know that that's the case. And so we're continuing to work through that and evolve and continue to roll that out across different branches across the country.
That's very relevant to Tyrone question, who's asking whether we've learned anything about climate change as a result of the COVID-19 pandemic. Is there anything that you'd like to add to that, and maybe add anything about how machine learning has played a role in studying the effects of COVID-19 and what we've learned for
Sure.
Yeah, I mean, again, in that, sorry, I'm sure Sasha can add more to the broader COVID-19 question. I think, it was about the recognition of, just because you've got these machine learning tools that have learned based on activities of the last, couple of years, you still have to recognize that all those things could change, right? And I think that it put us in a much more dramatic situation than we certainly expected. But at the same time, I think then we've been able to prove out that it still can help. You just have to be able to adjust the models. And it's looking at different external data. So if you think of cross-border activity between the US and Canada, might look very different right now because of a little closed border activity going on. And so again, the data from 2 years ago is just of almost zero relevance versus where things have opened up again, and in different regions that have different things opening, that data is useful again, right? So I think it's about being able to continue to model that and let it evolve, naturally, but not turning around and saying, well, the stuff from 2 years ago isn't relevant. It's just probably going to take some time before it is relevant.
I was going to add is that what we learned is that climate change has been slowed down very, very slightly by the COVID pandemic, just because of less travel, things like that. But also on the grand scale of things, it's just a little blip. Like if you look at the trajectories of carbon emissions, of greenhouse gas emissions in general, I mean, we have I think it's like a 7 or 9% drop in 2020, but it's still growing exponentially or almost, and we still need to kind of bring it down if we want to hit either the Paris Agreement or things like that. So essentially, I think we realized that it's even measures that have been enforced are not enough, that we need like overhauls, we need more major changes to happen, even because even grounding planes is not sufficient, and then it comes at such a big societal impact. So I think this has been a turning point for a lot of people in their minds, and realizing what it's going to take in order to move the needle on climate change.
Yeah, Tyrone's comment there, actually it's a pretty interesting comment, because now, in theory, we should really be using machine learning to accommodate the physical models that COVID-19 has broken. I mean, Sasha's right, the blip isn't all that particularly significant, but this is one pandemic. I mean, the presumption is that this is not the last pandemic we encounter, unfortunately. And so the resilience of the physical models is somewhat in question, because COVID comes along and puts a blip in the predictive, and those physical models aren't predicting this. So I think there is absolutely a role for machine learning there, and I don't think we've really taken advantage of that. So Tyrone's got a good point.
Absolutely. So diving into specifically what kind of recommendations you'd have for anybody to follow with your footsteps of working on climate change and machine learning. Do you have any recommendations of other than looking at external sources, as Jules mentioned, and looking at these different problems from a particular length? What have you found to be successful for you in your careers?
Arthur, I think you've got the most insight in terms of length.
Yes, I'm starting to feel old.
I was going to say wise, but okay.
So I think the place I would go with this is multidisciplinary. So we do tend to think rather in buckets, and we think about machine learning as a bucket. And the thing that I've encouraged with considerable vigor, to the annoyance of my neighbors, has been that these technologies really need to be together. They need to cooperate, they need to work in an integrated fashion. And the example I'll throw out there is that, so my background originally was in location intelligence. It's a specialty that I've spent quite a bit of time on. And let me hasten to add that that's not just putting things on maps. There's a considerable amount of analytics, as Jules will attest, there's a considerable amount of analytics to go on behind the scenes for this. But when we put machine learning and location intelligence together in the same story, where the machine learning engine could learn from the location intelligence capabilities, and where the location intelligence capabilities were fed from machine learning inferences, the multiplier was enormous. The difference that it made to the models that we were working on was quantifiable and a very big number that I won't mention, but it was very, very effective. So that's just one data science collaboration. What if we add some of the other data sciences in there? What if we've got statisticians working in that space? What if we've got some of the softer social data sciences working in those spaces? To me, that's the big opportunity for a win, particularly in climate change, because climate change isn't just about the physics, it's about people as well. And if you understand all of the factors that go into this, not just the location bit, not just the capability to use machine learning to predict from that, but incorporating the whole set of data
and building
science.
Upon that,
I kind of ranted a little bit
no,
there.
No, you're totally right.
Sorry.
And I think that, well, for example, last year we wrote a paper that's almost 100 pages long. And essentially what we tried to do is to reiterate the fact that AI is not going to solve all the issues, and you have to reach out to partners that don't. This is like this happens all the time with AI people. They learn about a problem, say climate change or anything, right? And then they're like, oh, hey, I'm really good at reinforcement learning. I'm going to use reinforcement learning to solve climate change. And you're like, no, there's so many people who have been working on this for decades. Like, really, this is not a new issue. and like reach out to your local university, companies, whatever, right? And make those connections, offer your skills. And so we keep on saying machine learning is no silver bullet because, like, I mean, for sure there's hype around AI, but it's not going to solve all these issues. You need domain knowledge, and that's in climate change. I think 99% of problems you need domain knowledge. You can't just like, you know, throw an algorithm at the data and then solve it. And essentially what we did is we pre-chewed a lot of the things that people are working on, and we made a grid of like AI approaches, like natural language processing, computer vision, time series, whatnot, and then like sectors, energy, transportation, finance. And then we tried to make a grid and say, okay, hey, you're good at reinforcement learning and you have a thing for finance. So like go there and learn about these people and connect with them, and to make sure that people don't try to reinvent the wheel just because they can use AI.
Yeah, I mean, I think, you know, on top of that, I see a question from Juan there about the work that we're doing with RBC Tech for Nature, which is investments we're making with universities and charities that are working on different technologies that are around, again, not just climate change, but climate change and environmentally relevant topics, right? And I think this is the same thing that we see across everything from a technology perspective. The cycles are so much faster than they used to be, right? So if you're a Python coder now, that does not mean you're going to be a Python coder 10 years from now, because there's going to be something else. So to your point, Sasha, of kind of thinking of that grid of both where your interests are and what your skills are, we do that a lot across the teams and try and share people. So whether that's, you know, working in Arthur's team for a period of time, but then going and doing something else and then coming back, right? So I know on these events, we tend to have a lot of students, and, you know, we have huge student programs that we manage across the technology teams, which that's really what it's about, is getting them to continue to advance their capabilities. I hate to break it to you, but when you get out of school, you just get to learn more. You just learn more at a company. And, you know, we're continuing to see this evolution. So I don't think that machine learning is the answer. I don't think there's one answer to climate change. And, you know, where you stop thinking about it, again, is a very hard line to draw. And, you know, I think it's all about getting everybody working toward, you know, driving climate change, reducing carbon emissions, right? I think trying to be too precise about that can be challenging, but I think what we do is try and make sure that everybody has different opportunities for different experiences.
So diving a little bit more into Juan's question that you addressed, he's asking whether or not there are any suggestions for projects that require support from machine learning engineers, machine learning researchers that you'd recommend.
I've seen a few just pop.
I mean, I'd have to, yeah.
For example, there's one that I found really interesting. Like, for example, climate data, like historical climate data, has been around since something like the 1800s, but it's mostly on paper, right? And so I saw like a call out on Twitter for help using OCR, like optic character recognition, so computer vision, essentially to digitize these records, because essentially we're missing out on almost, you know, 2 centuries rather of data that we aren't utilizing in most of these climate models. And it's a fairly simple task. I mean, but you know, you have to scan it properly, use parse the little squares or whatnot. So I mean, there's a lot to be done. It's not just like a throw your algorithm at it problem. So it's actually pretty interesting. And I mean, I haven't seen this for climate change as such, but for example, for the COVID pandemic, there was a website that was created. It was like data against COVID. And what was cool is that medical practitioners or scientists in the space could ask for help, and then they would be paired with AI or data scientists, et cetera, that could have the skills that they need. And so I think that it would really be great to have this kind of matching up, like kind of platform for climate change as well, because there's so many small issues. And the thing is, you need to move the needle on so many small issues. Like, it's not going to be one solution. It's going to be a million solutions. So having these kinds of pairing would be really interesting. But just like reach out to your local, you know, climate scientists and be like, hey, can I help? Or whatever sector you're interested in. It could be agriculture, transportation, like you name it.
I have a suggestion for Juan's last question there that I'd like to throw out. So there is a company, and I'm not going to do a commercial for it, but there's a company that has invented a way of sequestering carbon in concrete as it's poured. And what happens is that the concrete that's poured is significantly stronger and significantly harder than normal concrete. meaning that there's an enormous amount of money saved because you're pouring less concrete and so on and so forth. Southern Initiative, very obviously, RBC is all over that one to help fund it, which is cool, but it's not, we've not subjected it to analytics. So the obvious thing then is you put machine learning in place to understand what the impact of that's going to be. How much carbon did we sequester? Where are places where it's even practical to supplant the concrete that's there with the hardened concrete, and so on and so forth. So the analytics, so I think there's a lot of these really kind of cool ideas out there for sequestering carbon, but we're not, we actually need some really smart machine learning analysts, location intelligence specialists, and so forth to be paying attention to this so that the impact of it is illustrated. Because as soon as you illustrate that impact, money flows, and all of a sudden climate change, we're doing good things for climate change.
One of the relevant questions here is from Tzvi, who's asking whether there are any interesting AI ML applications in agricultural technologies. Would you happen to know?
So I know Tzvi quite well, and I'm calling him out for putting a suggestive question in there. I can certainly attack that one though. As Tzvi knows, we've spent quite a bit of time actually with him and with other organizations understanding from the agriculture section, and this is going to be a slight commercial for RBC. We spend a lot of effort in the ag segment helping people understand how to change practices that improve the carbon footprint, or actually even better, the carbon sequestration. Those are more physical models. The machine learning models that are wrapped over the top of those are still fledgling. We haven't spent an enormous amount of effort on them yet, but it's a very obvious target for us.
And how do you think these will change food production in Canada?
I see a cat. Where's Dante, Jules? He's been sequestered, has he? I'm sorry.
Food production
Patricia,
in Canada.
Distracted you.
Oh, no problem.
Yes.
I was asking how you think those
Well,
innovations
one
will
general
affect food
application of
production in
AI
Canada.
is like precision agriculture. So I think that's something, I mean, it's an umbrella term, right? But I think that it can make a big impact on essentially, for example, figuring out how to optimize production in a given area. I think that, I mean, in developed countries in general, we're using more of these technologies already. Like they have drones that fly out and measure humidity, they measure things like that. And you can actually say, you know, like I was reading the case for a vineyard somewhere near Niagara Falls. It was like, we know that we should plant these grapes here because, you know, they have a 0.2% more humidity in that particular area, and the drones told us. So I found that was really futuristic, but in general, this can be used for anything. I mean, I guess grapes are more finicky, but, you know, corn or wheat or whatever can profit from this kind of more precise, like, because the way we're doing it now is the way we've been doing it for a while, plus a bit of GMOs. But other than that, like, we haven't really dug deep on, like, you know, a very, like a narrow level in terms of like farmland and even sectors of a given farm.
Yeah, it's interesting, Sasha, that you mentioned Vineyards, because that's come across our desk as well. So we've actually built machine learning models in combination with location intelligence that predict the climate change effects, so that vintners can actually change the way that they've laid out their vines, or they change the way that they're pruning the vines, or the watering process, and so forth, so that they are actually preparing themselves for the climate change that's coming.
Brilliant. If the audience has any more questions that they'd like to post in the channel, it's question period now. So please feel free to put those in the chat. We've got one question that's reiterating the role of retail companies in contributing to the mitigation of climate change. We addressed that to a certain amount, but to a certain extent, I guess it also depends on the size of the retail company. So from smaller to larger organizations, what do you think that the differences are in the impact that they can make and the changes that they can contribute with?
Well, of course, retail companies have an enormous advantage in the data that they accumulate because they have a very fine-grained understanding of the transactions they execute, what people buy, and the impact of what they buy is something that's actually traceable. It is possible to put a carbon footprint on everything that's on every shelf in every retail store, even down to clothing. And so it's a burden for a retail company to do the analytics on that. So I think there is a role here for AI companies to actually walk in and go, we can help you with some prediction based on this. We can help you understand your carbon footprint. We can help you understand how you're contributing to the mitigation. And that's money. That's money well spent, but it's also worth money. Because if you can go out and say, buy this product instead of this product, and you're reducing the carbon footprint, it's not a bad thing.
Extension recently that does this. Like, it essentially tells you, oh, you want to buy this item, but if you buy this one, it's more local, or it's less carbon intensive. So I found that was pretty cool, because it really, I guess, gives people the power to make those choices. Like, if you have two equivalent objects or more or less, you can at least have that choice.
Yeah, I mean, I think it's the
actually.
If you think about the buy local initiatives, whether it's farm to table, if we think of restaurants or retailers of food, right? I mean, I think a lot of this has been kind of overrun with the work that is being done because of the COVID pandemic, right? So stores are doing more at trying to figure out, how do you only come once a week, right? So it used to be, oh, let's increase foot traffic. And now it's decreased foot traffic, right? So some of this is driving some different things, not only focused on climate change, but looking at the overall, retail market and how we think about some of these things differently. At the end of the day, it drives logistics challenges on both sides, right? So whether you're trying to figure out, well, how do I do more to buy local to reduce my carbon footprint, or to ensure the safety of the item that I'm buying, right? So they become more and more hooked as we continue the length of time that we're in this pandemic.
There's a company called Localized, and I don't hesitate in giving them a bit of a commercial. And what they do is they estimate for every product that's on the shelf how local it is. So it's a sliding scale, and there's an index. So there are grocery stores actually here in Toronto who actually use Localized. And if you walk past, you'll see on the shelf, the front of the shelf, it says the product and the price and all that kind of stuff. And then it has a localized score. And people are deliberately choosing local product, even though it might be a bit more expensive, or, the packaging isn't quite as good, or something or other. But I think we can do exactly the same thing with carbon, and let people make those choices. And when the analytics, when the machine learning behind that kicks in, there's going to be a lot of change in the way those products are actually created. And I think that's an awesome initiative. But it's got to sort of start with the consumers making the choice.
Thank you. So we've got 1 minute left. I'm going to point out that RBC has a virtual booth where you could go and talk to Arthur and Jules about further questions you might have about machine learning and climate change. And Sasha, earlier in the chat, there was a question about what the name or the GitHub repo is that might contain the project you mentioned for determining what
it's called Code Carbon. I'll send the GitHub link.
Perfect. There are still a huge amount of questions, so the speakers might tell you that you could feel free to reach out to them if you want to keep.
No, 45 minutes
going.
went fast.
Yeah, I'm happy. It's actually did, yes.
Well, thank you three very much. I think I speak for all of us when I say that this has been a fascinating panel, and I've learned a lot from it.
Thank you.
Thanks so much
for having us.
Take care.
Thanks, everybody.